Hello, this video is to show you how to go from table to an equation using finite differences. So first off, looking at this table, what you would do is you would subtract the y value from the one above it. So if I do -5 minus a -9, I would get 4. 7 minus a -5 would be 12. 27 minus 7 is 20. 55 minus 27 is 28, and you would keep doing those differences. Now, if the number was the same every single time you did that, it would be linear for the first difference. Obviously, these numbers are not the same, so we're going to have to do what's called the difference of the differences. So we're going to subtract this one more time. So 12 minus 4 is 8, 20 minus 12 is 8, 28 minus 20 is 8, and you can see that every time, the second time, I get the same number. So if that happens, then this means this is a quadratic equation. Again, if it happened the first time, it would be linear. And so what's special about writing the equation using finite differences is once you have the second difference, you just take half of that second difference, and that's going to be your a value. So remember, the standard notation for quadratic is y equals ax squared plus bx plus c. So then right now, if I take half of 8, which is 4, I know my a value is 4. Also from our conversation in class, we know that the c value is always our y-intercept. So if I look at my table, when x is 0, whatever y is my y-intercept. So I know 2 of my 3 values I need for my equation. What some of you are asking about is, how do I find the b value? Well, all I usually do is I take 1, which is x. When I plug that in, 1 squared is 1 times 4 is 4 minus 5 is -1. Then you have to ask yourself, how can I go from -1 to +7? And in order to do that, I would need a +8. So that ends up being my b value. So this equation using for this table of values would be y equals 4x squared plus 8x minus 5.